What if reality as you know it is only a fraction of the whole truth? What if the universe operates differently at the smallest scales? Welcome to the world of quantum mechanics, a realm where the rules of the game change, where the ordinary becomes extraordinary. Quantum mechanics is the study of matter and energy at their most fundamental, in the realm of the atomic and subatomic. In the early 20th century, scientists began to notice that classical physics, the physics that describes the world as we know it, was falling short. It couldn't explain certain phenomena on a smaller scale. The observed inconsistencies between what was happening in the lab and what classical physics predicted led to a revolution in science, and thus quantum mechanics was born. Quantum mechanics is like a rebellious teenager, challenging our conventional wisdom and throwing curveballs at every turn. Take the uncertainty principle, for instance. This principle states that you cannot know both the position and the velocity of a particle with absolute certainty. The more precisely one measures one quantity, the less precisely the other can be known. This defies our everyday logic, where we can know both the speed and the location of, say, a car at any given moment. Then there's entanglement, another mind-boggling concept. Imagine two particles that have interacted in the past. Now, these particles could be light years apart, but if you measure a property of one, the other instantly reflects a corresponding change, as if they were still connected. It's like magic, but it's not. It's quantum mechanics. Quantum mechanics, in essence, is the key to understanding the universe in a way that defies our everyday intuition. It's a peek into the hidden layers of reality, a journey into the microscopic world that governs the universe as we know it. So buckle up as we delve deeper into this enigma of quantum mechanics. The birth of quantum mechanics was not an overnight phenomenon. It was a revolution, one that challenged and reshaped our understanding of the universe. The seeds of this revolution were planted in the late 19th century with the discovery of electrons. This shattered the belief that matter was continuous, introducing the concept of particles, the fundamental building blocks of matter. Around the same time, we were grappling with the mysteries of blackbody radiation. Classical physics predicted an infinite amount of energy at high frequencies, an absurdity that came to be known as the ultraviolet catastrophe. Quantum mechanics came to the rescue, explaining that energy, like matter, was quantized, not continuous. Among the pivotal contributors to the quantum revolution was none other than Albert Einstein. Although best known for his theory of relativity, Einstein also proposed that light, long thought to be a wave, also had particle-like properties. He introduced the concept of light as energy quanta, packets of energy, to explain the photoelectric effect. This dual nature of light, both wave and particle, became a cornerstone of quantum mechanics. Even the seemingly mundane phenomenon of light passing through gas was a piece in the quantum puzzle. The regularity of absorption lines in this light hinted at a hidden order within the atom, an order later explained by the quantum mechanical model of atomic structure. The final pieces fell into place with the work of Otto Stern and Walter Gerlach. They demonstrated the magnetic properties of silver atoms, revealing yet another quantum surprise, the concept of spin. This challenged classical explanations and solidified the quantum view of the world. Each of these discoveries, in their own unique way, nudged us closer to the quantum revolution. So how does quantum mechanics shape our reality, and what implications does it have for our understanding of the universe? Quantum mechanics, in its unique and counterintuitive way, forms the very basis of our reality. It's like the backstage crew of a theater production, unseen, yet indispensable. To understand how, we first need to delve into the world of chemistry. Chemistry, at its core, is about atoms and their interactions, forming the molecules that make up everything around us, from the air we breathe to the coffee we drink. But what dictates these interactions? You guessed it, quantum mechanics. It's the set of rules that govern the behavior of atoms and subatomic particles like electrons and photons. Without it, we wouldn't have a clue why hydrogen and oxygen combine to form water, or why neon doesn't react with anything at all. Quantum mechanics is also responsible for some truly remarkable phenomena. one of which is superfluidity. Imagine a liquid that can flow without any resistance, even climbing up the walls of its container and dripping out from the top. No, this isn't a scene from a science fiction movie, but a real-world phenomenon observed in liquid helium when it's cooled to near absolute zero. This mind-boggling behavior is a direct result of quantum mechanics and is something that classical physics fails to explain. Beyond the realm of chemistry and superfluidity, quantum mechanics introduces us to the concept of entanglement. It's a strange phenomenon where two particles become intertwined in such a way that the state of one instantly influences the other, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, challenges our everyday notions of space and time. Entanglement could have profound implications for our understanding of the universe. It suggests that at a fundamental level, the universe might be deeply interconnected in ways we're just starting to comprehend. It could even open up new possibilities in technology, from quantum computing to quantum teleportation. Quantum mechanics, thus, gives us a new lens to view and understand the universe, one that transcends the boundaries of classical physics. The quantum revolution was not just a shift in understanding. It was a shift that has had and will continue to have profound implications for our world. Quantum mechanics, a field that emerged in the early part of the 20th century, has undeniably made a significant impact on modern science and technology. Its principles have paved the way for advancements in various fields, revolutionizing our understanding of the universe and life as we know it. Imagine the world of technology without quantum mechanics. The very device you're using to watch this video, your smartphone, your computer, they all rely on the principles of quantum mechanics. The miniaturization of electronic components, the foundation of modern computing, is all thanks to the understanding of quantum phenomena. Quantum mechanics has allowed us to manipulate individual atoms and electrons, opening up new possibilities in nanotechnology. The field of medicine has also reaped the benefits of quantum mechanics. Medical imaging techniques like MRI, which help doctors see inside the human body without surgery, are based on quantum physics. The very principles that puzzled and sometimes frustrated even the brightest minds are now used to save lives. But perhaps the most exciting potential of quantum mechanics lies in the field of quantum computing. While still in its early stages, quantum computing promises to revolutionize the way we process information, solve complex problems, and even understand the universe itself. This is a field where bits are replaced by qubits, and computations are not just faster, but fundamentally different. And this is just the tip of the iceberg. Quantum mechanics continues to open doors to new scientific and technological landscapes. From the development of quantum materials with exotic properties to quantum sensors with unprecedented precision, the possibilities are truly limitless. Quantum mechanics, in its peculiar and profound ways, continues to shape our understanding of the universe and drive progress in ways we could not have imagined. Its influence is far-reaching and transformative, and as we continue to unravel its mysteries, who knows what other revolutionary breakthroughs await us in the quantum realm. From challenging our classical understanding of physics to reshaping our view of reality, the journey through quantum mechanics is nothing short of a mind-bending adventure. We've dived into this mysterious world, where classical physics takes a back seat, and paradoxes like the uncertainty principle and entanglement become the norm. We've seen how this tiny realm of atoms and subatomic particles has a gigantic impact on everything we know, from the chemistry that forms molecules to phenomena like superfluidity that defy classical explanation. And we've learned that despite its counterintuitive nature, quantum mechanics is not just a theoretical playground. It's fundamental to our understanding of the universe and the technologies we use every day. So the next time you look at the stars, remember the universe is not just what meets the eye. It's a quantum world out there, a world of endless possibilities and paradoxes.